The topic is homogeneous linear equations with constant coefficients, and this is the case of third order DEs. So let's do this example. We're trying to solve the third derivative of y plus 3, first derivative of y minus 4y equals 0. So again, the first thing we do is write the auxiliary equation. So in this case, it's going to be m cubed plus 3m minus 4 is equal 0. So again, we need to solve a third degree equation. Not like previous example, it was easier because we could solve it just by grouping, factor by grouping. In this case, we can't factor by grouping. So what we do, we use the rational zero test. So let me write it here. The rational zero test says that the zeros of a polynomial of f of x equal a(n)xn plus blah blah a1x plus a0. If there is any, let me write it down, if p over q is a 0 of this function, of course it's in lowest terms, p over q. So if it's a 0, then p is a factor of the term a0, and then q is the factor of an. So in this case, if there is any 0 for this equation, and if it has the form p over q, meaning a rational 0, then p is the multiple of a0. Remember, a0 is what? This is a0 is negative 4. So p is going to be equal, multiple of a0 will be minus plus 1, or minus plus 2, or minus plus 4. Now same thing for the q. The q will be a multiple of an. An is equal to 1. These are 1 here. This is an. So q can only be minus or plus 1. Those are the multiple of 1. So remember, p is a factor of negative 4. And this gives us all of these. And q is a factor of 1. So these are factors. Let me write them. These are factors of 1. And these are factors of 4. Right? Factors of 4 are minus plus 1, minus plus 2, minus plus 4. Factors of 1 are minus plus 1. So p over q will be what? If you do so it's a minus plus 1 over minus plus 1, minus plus 2 over minus plus 1, minus plus 4 over minus plus 1. So in other words, if there are any rational zeros, they will be either minus 1, plus 1, minus 2, plus 2, minus 4, plus 4. It has to be one of these. So all we need to do is test these numbers. So let's plug them in and see which one is going to give us 0. If you plug a negative 1 into here, so we get negative 1 cube plus 3 times negative 1 minus 4, and this is minus 1 minus 3 minus 4 minus 4, negative 8. This does not work. So let's try 1. As long as one of them works, you'll stop. So let's try 1. 1 cube plus 3 times 1 minus 4. This is 4 minus 4 equals 0. It works. We're done. So now we know that 1 is a 0. So therefore, we can divide So therefore we can divide m cubed plus 3m minus 4 can be divided by m minus the 0, which is m minus 1. Alright, so how do we divide this? We need m squared. M squared times m is m cubed. M squared times minus 1 is minus m squared. Now all I do, I multiply this by minus and then add. If I add m cubed minus m cubed is gone, 3m, so this will be, so 4m squared. I just realized there's a mistake here. This is supposed to be m squared, right? And so this is m squared. So I'm adding these, I get 4m squared minus 4. Now here all I do is I multiply. What do I multiply by m to get 4m squared? So of course this is 4m. 4m times m is 4m squared. 4m times negative 1 is minus 4m. Again I multiply this by negative and then add. If I add, I get 4m minus 4. Now all I need to do, multiply by 4. 4m minus 4 multiplied by negative, add, you get a 0, so it's fine. So basically this equation 1 becomes m minus 1 factor of m squared plus 4m plus 4 is equal 0. Now this means the m is equal 1, or m is equal, actually this is the same thing as, let's factor this one. This is m minus 1, this is m plus 2, m plus 2, right? M squared, yeah. So this is m1 equal 1, m2 equal negative 2, m3 is equal negative 2. So now y is supposed to be, the way we do it, y is equal c1e m1x, which is 1 times x, plus c2e negative 2x plus c3e negative 2x. But since these are repeating, so you multiply the second one by x, and that's your general solution. And that's it for this example.